everyone, welcome to my content video presentation for the course Statistical Learning and Data Science. It will be presented by me, Dr. Rufeida Swekri. Here I have chosen to present the first chapter, Data and Statistical Learning, which consists of two sections. The first section is entitled Foundations of Data Science. The second one, Introduction to Statistical Learning. Let's start the first section by defining what data science means. Data science is the extraction of knowledge from data using ideas from mathematics, statistics, machine learning, computer science, engineering, and so on. Everything in data science begins with one essential element, data itself. So, what exactly is data? Data can be defined as a collection of raw facts or numbers, which when processed can provide meaningful information. As example, we have a list of numbers like 10, 20, and 30. Represent data. However, when we say these numbers represent the ages of students in a class, it becomes information. Now that we have answered the what, it is time to look at which, as in which types of data are out there. This diagram shows or illustrates the two main groups of data types. We have qualitative data and quantitative data. We start by explaining what is qualitative data or attributes. We call it also categorical data. Categorical data describe characteristics that do not have numerical significance that are used to classify data into distinct categories. That's why we call it also categorical data. They are further divided into two main groups. Nominal data represents categories that do not have a meaningful order or ranking. Ordinal data, unlike nominal data, ordinal attributes have a logical sequence or ranking. But the difference between categories is not necessarily uniform. Now, what is quantitative data or numerical data? Numerical data represents logically numerical values that can be measured and counted. They are further divided into two main groups: discrete data, continuous data. Discrete data are countable numbers with a finite or fixed number of values. Continuous data are measurable values that can take an infinite number of possibilities within a given range. Continuous data can have decimal or fractional values. Before we can apply any statistical or machine learning techniques, we need to make sure our data is clean and ready. So let's talk about data pre-processing. Data pre-processing in data science refers to a series of techniques applied to raw data to improve its quality and structure before applying statistical or machine learning algorithms. We have here the key data pre-processing steps. We have 6 steps: data profiling, data cleansing, data reduction, data transformation, data enrichment, and data validation. Now that we have prepared our data, the next question is how to analyze it. The answer lies in statistical learning. What is statistical learning? Statistical learning is a subfield of statistics that focuses on using data to build models, uncover patterns, and make predictions while accounting for uncertainty. It forms a bridge between statistics and machine learning. So, statistical learning is a combination between machine learning and applied statistics. From applied statistics, it borrows probabilistic reasoning, inference, hypothesis, testing, and confidence intervals. From machine learning, it adopts algorithms for prediction, classification, and pattern recognition, often optimized for performance on large data sets. Lastly, to deepen our knowledge, let's examine the two major types of statistical learning. We have unsupervised learning, and supervised learning. The model in supervised learning is trained on labeled data and learns to make predictions or classifications. We have two groups, regression and classification. Regression to predict continuous outcomes. Classification is to predict discrete categories. For unsupervised learning, the models work with enabled data, seeking to discover hidden patterns or structure. We have three main groups. Clustering, in clustering we group similar data points. The famous algorithms, we have Camille's algorithm. For dimensionality reduction, we simplify data representation. The famous algorithm, principal component analysis. In the last group, association rules, we discover item-to-item relationships. We have the famous algorithm, a priori algorithm. Thank you for watching.